Two squares, each of side length 1 plus root 2 units overlap. The overlapping region is a regular octagon. So this is the kind of shape that we're going to get. And we're told that the length across here is 1 plus root 2. Now, because we have a regular octagon, then the angles inside are actually going to be 135, which means that this is going to be 45 and this is going to be 45, and we know this is 90. So we've necessarily got some isosceles right angle triangles going on. What I decided to do was call this length x, that is the sides of the octagon, and then this is going to be y, and I've got y over here as well. Actually, that one is going to be y, and that one is also going to be x. So I can write two equations down. I can write down that x plus 2y is equal to 1 plus root 2. And I can also write down, using Pythagoras' theorem, that y squared plus y squared is equal to x squared. Therefore, 2y squared is equal to x squared. And if I square root, I get that root 2y is equal to x. Now, there's a really nice thing we can do to speed things up. When I did it, I actually took a longer route, which I will talk about, but we can rewrite it as y is equal to x over root 2. And if I substitute that into this one, then I'm going to suddenly get that x plus 2 lots of x over root 2 is equal to 1 plus root 2. And 2 over root 2 is actually root 2, so it's x plus root 2x equals 1 plus root 2. That tries out the x. It must therefore be, without too much work, that x is equal to 1. And we're well on our way now. In fact, there's a really nice way of dealing. So I want to basically find the area of the square, which is going to be 1 plus root 2 squared, and then subtract these green triangles. But we can bring these green triangles together. So if I take the bottom right, the bottom left, and then that's the top left, top right, what I'm actually going to create is a 1 by 1 square. So the green area is in fact just going to be 1. And therefore, if I want the area of the octagon, this purple area of octagon is going to be 1 plus root 2 squared minus that green area, 1. So expand the double bracket. This is actually 1 plus root 2 times 1 plus root 2. So we'll get 1 plus 2 root 2 plus 2 minus 1. The 1 and minus 1 cancel, leaving us an answer of 2 plus root 2, which gives us, I was about to say C, but no, 2 plus 2 root 2 gives us D. When I did this question, I didn't do it quite as succinctly as this, to be fair. So I'm going to talk about how I did it. I stuck with the x equals 2 root 2y. And I didn't think to write y equals x over root 2. And then I actually substituted that into this equation here. So it becomes, it becomes root 2y plus 2y is equal to 1 plus root 2. That tries out the y. And then I went with the exact value for y, so y is equal to 1 plus root 2 over 2 plus root 2. And to be honest, originally I then tried to work out the area of the triangle using that, but when I did it a second time, I decided to first of all simplify the surd, and I do think that is a good idea. So I rationalized the denominator second time I did it, times by 2 minus root 2 this is just double brackets going on. So we get 2, we get minus root 2 plus 2 root 2. So it's plus root 2 and then minus 2. So this nicely just cancels out. And over here, we've actually got a difference of 2 squares. So we get 4 minus 2 root 2 plus 2 root 2 minus 2. So this actually gives simply root 2 over 2, or 1 over root 2. So now I've got 1 over root 2 here and 1 over root 2 here. So I can work out the area of that triangle, a half times 1 over root 2 times 1 over root 2. And then there's 4 lots of them. And this ends up again being 1 because I get a half here, I get a half here, I just get 1. So it's a little bit more complicated, but you can see it also works. And yes, still, you can't expect to always go with the quickest solution for this problem. It still gets me there pretty fast. All right, well done on your efforts on this challenge and this question in particular.